The elevator door closes, the street disappears, and the passenger takes escalators down to nearly 50 meters below ground in São Paulo. Above him, the city keeps running. Avenues, railways, buildings, pipelines, cables, and galleries. This is Água Branca station on Line 6 Orange. At almost 48 meters deep, the São Paulo government presents it as the deepest station in operation in Latin America. That's equivalent to a 15-story building buried under Santa Marina Avenue. However, the record is not expected to last long. On Line 6 itself, another station is already under construction, almost 18 meters below it. Why did São Paulo need to go so deep, and how do you build a structure of this size without compromising the city that operates on the surface? Stay with us for the next few minutes and find out how Água Branca station was built, why Line 6 goes so deep under São Paulo, and how much longer until the current record is broken. Água Branca station is part of a much larger project. Line 6 Orange was designed to connect Brasilândia in the north zone to São Joaquim in the central region. The route will be 15.3 kilometers long and have 15 stations passing through densely populated neighborhoods and creating connections with the subway network. According to Linha Uni, the route, which currently can take about an hour and a half by bus, should drop to approximately 23 minutes. The forecast is to serve about 633,000 passengers per day when the line is complete. In addition to its scale, the project carries a history of interruption and resumption. After years of being halted, construction resumed in 2019. Through a public-private partnership that brings together implementation and operation. The depth of Água Branca station, however, did not come from a desire to break records. To save more than an hour of travel on the surface, the engineers had to look for space where São Paulo still allowed them to go dozens of meters below it. And a very valid question that comes up is what already existed in this underground path? The underground path of Line C was already occupied before the project even left the drawing board, long before. In Água Branca, the railway history began in 1867 with the opening of the São Paulo railway station. In 1875, the arrival of the Sorocaba Railway turned the area into an interchange point and a freight hub. Then came the Santa Marina Glassworks in 1896 and the Mataracho Industries Complex in 1920, consolidating a territory of tracks, factories, warehouses, and neighborhoods that grew around them. The subway tried to get there several times. At the end of the 1970s, Água Branca was considered as the final stop of the East-West Line, now known as the Line 3 Red. The plan did not move forward. Then a proposal came up associated with Corobo, Top West Plaza, also abandoned. In 2005, the region reappeared in the distribution network. In 2008, in the Project for the Future, Line 6 Orange. When this connection finally started to be implemented, it found an already built-up city, both above and below ground. In addition, the route needed to pass under the Tietê River and in another section, below the tunnel of Line 4 Yellow, respecting limits for curves, ramps, and safety distances. So the depth did not come from a desire to break records. It was the solution found to insert a new line into territory that had been occupied for over a century. In certain sections, there was no room to go around. It was necessary to go down. However, setting this depth level was just the first challenge. The question that arose was how to excavate and support a station of this size without compromising the city above. According to the company responsible for the project, Linha Uni, the structure of Água Branca station is already considered finished. It reaches 47.80 meters in depth, is located next to Santa Marina Avenue, and was excavated using the NATM method. However, the completion of the station does not mean that the entire Line 6 is ready. Other stations and systems are still being implemented, and Tabaraba Hospital Vila Penteado, for example, is still under construction. NATM, which stands for New Austrian Tunneling Method, combines excavation, support, and monitoring. In this method, the front advances in stages. A portion of soil is removed, and before the next advance, the newly exposed surface receives special support. This process is necessary because an underground cavity cannot remain open while waiting for the final structure. The ground may deform, shift, or lose stability. The initial support limits these movements and allows the work to continue safely. At this point, shotcrete comes into play. Unlike traditional concrete, it is applied under pressure directly onto the excavated surface. As a result, a layer of protection and support is created. Depending on the terrain and the project, shotcrete can work with fibers, wire mesh, steel ribs, anchors, and other elements. Each section is opened, stabilized, and measured before the team moves forward again. In a wide section, the upper part can be excavated first. Then excavation proceeds through the sides and the lower section. Each step reduces the exposed ground and allows support to be installed close to the working face. In this process, the ground itself takes part in the structure. This doesn't mean the ground is unsupported. The goal is to control its deformations and make the ground mass, the initial support, and the lining work together. That's why monitoring is crucial. Instruments monitor displacements in the ground and in the lining to respond accordingly. Is the excavation behaving as expected? If the measurements indicate different behavior, the project may require reinforcements, a reduction in the excavation advance, or a change in sequence. Therefore, NATM should not be reduced to something improvised during the excavation. There is a design, deformation limits, and planned solutions. Monitoring allows us to check how the ground responds and adjust the execution. Once the initial support is completed, the station is still far from being ready. The excavation needs to be closed at the bottom, forming a kind of load-bearing ring. Ceiling and base walls start to work together, increasing the stability of the section. Next come drainage, waterproofing, and permanent lining. The purpose is to control water ingress and turn a temporary cavity into a structure prepared for decades of use. From then on, the excavated space stops looking like a big cave and starts functioning as a station. It's important to state that NATM is also not synonymous with the tunnel boring machine. The tunnel boring machines, known as TBMs or tunnel moles, move forward continuously and open normally circular tunnels, forming the tubes through which the trains run. The station, however, requires a different geometry. It needs to accommodate platforms, stairs, elevators, corridors, technical areas, and emergency exits. These are larger spaces with different shapes. Sequential excavation allows for building these caverns and connections with more flexibility. Besides the method, the depth changes the logistics. All the material removed needs to be lifted almost 50 meters. Concrete, steel, equipment, and workers travel the other way. At the same time, ventilation, power, lighting, communication, and drainage need to work during the construction. Each work front must receive supplies without blocking the other activities. Finally, there is a less visible challenge: controlling the settlements. This term refers to the displacement of the ground caused by changes in stress in the subsoil. Even small movements can affect pavements, pipelines, foundations, or nearby buildings. That's why excavating in stages, quickly installing supports, and continuously measuring deformations is essential to limit this risk. At Agua Branca station, it's not just about reaching 47.8 meters. It's about opening, stabilizing, waterproofing, and equipping a huge cavity while São Paulo keeps operating above it. Imagine a 15-story building. Now turn that building upside down. That's approximately the depth of Agua Branca station, 47.8 meters. In Latin America, few stations have come close to that mark. Camarones, the deepest station in the Mexico City subway, reaches 40 meters. In Santiago, the tracks of Line 3 at Puente Calicanto are 33 meters below the surface. The San Francisco station, in the historic center of Quito, was built about 30 meters deep. In Buenos Aires once, the deepest station in the network reaches 22 meters. Agua Branca station goes down almost 8 meters deeper than Camarones, about 15 meters below Puente Calicanto, and more than twice the depth of once. But Line 6 itself will push that even further. At Tabaraba Hospital, Villa Panteado will be 65.71 meters, while at Higienopolis Mackenzie, it will reach 64.86 meters. Itabaraba will be almost 18 meters below Agua Branca, which is equivalent to a building of about 22 stories underground. Outside Latin America, some stations go even deeper. In Chongqing, China, Hongtianku Station reaches an impressive 116 meters at its deepest point. That's almost 2.5 times the depth of Agua Branca Station, and about the same as a 39-story building turned upside down. However, this comparison needs to be made carefully. Some sources measure the distance to the tracks, others consider the platform, the entrance, or the lowest structural point. Even without a perfectly standardized ranking and far from the deepest subway stations in the world, the scale is clear. Agua Branca Station ushers in a new standard for transit in São Paulo. In fact, depth is not the purpose of a station. It's an engineering requirement to bring destinations closer and reduce travel time. Agua Branca Station is part of Line 6 Orange and will be connected to Line 7 Ruby. With this, passengers from the north zone of São Paulo will be able to access the metropolitan network of 3 lines without relying on current road routes. The main projected benefit is time savings. According to Linha Uni, the trip between Brasilândia and São Joaquim, which is estimated to take an hour and a half by bus, should be completed in 23 minutes. The reduction reaches approximately 67 minutes, or almost 75% for those making an equivalent journey. The savings are not limited to the time spent inside the trains. A well-placed transfer point can reduce detours, waiting times, and transfers between buses, subways, and railways. In this sense, a study by the University of São Paulo that analyzed these systems as an integrated network showed that bringing stops and stations closer together can reduce the number of connections needed to reach destinations. The real benefit will be measured in minutes saved, fewer travel steps, and greater access to the network. After all, the station wasn't excavated to take passengers to the lowest point in the city. It was built to get them to their destination more quickly. For the passenger, it will all come down to a familiar routine: entering, going down, and waiting for the train. However, behind this routine, there will be a structure equivalent to a 15-story building buried beneath São Paulo. The record set by Agua Branca Station may not last long. Line C itself is already preparing to go even deeper. And the real test will begin when all this engineering stops being a construction site and starts operating every day as part of the city. Thank you for watching this video up to this point. Did you know that this station here in Brazil is the deepest in Latin America, and that we already expect to break our own record again on Line 6, the Orange Line here in São Paulo? It's something to admire, whether you like it or not, because it shows that our engineering has great potential, right? I'll stop here. Take care and see you in the next video.